Well, hi, good morning. Thanks so much for joining me here. It's March 11th. So yesterday I set out to do the audio alignment, the AM alignment on this radio, and I didn't get through square one with it before I got interested in the audio side of the radio and pretty much got totally lost. So the situation with this radio seems to be a little more complicated and a little bit beyond me for sure right now. So what I decided to do is take a more pragmatic approach to working on the radio, and I'm going to trace the audio as it comes in on the phono inputs and trace it step by step right through the radio, and painful as that is going to be, and see what happens. I'm not going to put this on video until I hit something interesting, which in many cases means the whole thing will end up on video, but I don't think that will be the case, because the work is very picky at this point, and I'm using the word work, I'm not using the word fun anymore. When it gets down to this level, it just becomes too serious to really have great pleasure in doing it, but it has to be done this way. So step by step, working my way through, see what I find, and my goal now is to get the audio side of this receiver working. I kind of skipped by that before and poked around with the radio side of it on the assumption that once the radio side was settled down I could then focus on the audio side. It's a little bit backwards. So here I am. So that's what I'm going to be doing. Wish me luck. I have a full cup of coffee to help out with this. Okay, so I really haven't started any actual troubleshooting or circuit tracing or anything yet, but I have set up the receiver. I just wanted to say how I've done this. I don't want to use the record player, that's a bit of a hassle. So instead, because I have a Bluetooth receiver in my shop here, I'm using the Bluetooth receiver as an input to the radio. It's a similar output level to the record player. So I'm just going to turn the volume up briefly so you can hear what this sounds like right now, and it's only coming out of that speaker up there. So lots of volume, although I do have the volume control turned up fairly high. One channel absent. Let me just turn the control and try again. Okay, I'm going to disconnect that speaker up there so we can't hear it anymore. What do we hear now from the problematic channel? It sounds like one channel is actually working quite well. So that's what I'm going after. Going after that weak channel. And the thing about using the Bluetooth receiver, my phone is the actual source of what I'm using something called Radio Player Canada, which is a application you can put on your smartphone, and you can access virtually every radio station in Canada through it. So I'm actually listening to a local FM station I can pick up on my radios through my phone, pumping it through here. So okay, time to get busy and see what I come across. Okay, I think this is fruitful. So I've just been tracking my way through from the phono input, tracing both channels, having the set put in stereo, and the signal is strong, but pretty hard time getting through here. This is where I replaced all those capacitors on that little board. On the other side we encounter the volume control, which I've sorted out now finally after pulling my hair out yesterday. So I know which is going on with the volume control. Think about this. So the tone control only has a quarter turn, oddly enough. It's a three-part combination or gained potentiometer in there, three potentiometers. One of them has leads coming out the bottom and the top, or the other way around, the bottom and the top. So inside, if you imagine, if the wipers to go all the way around like most potentiometers, how could you have leads coming out the bottom and the top? The only way would be to have two half potentiometers or quarter potentiometers inside one little potentiometer box, leads coming out two different places. and then restrict the movement of the wiper so it only goes, I would think, half a turn, but maybe a quarter turn. So that's the balance control. On the volume control is their usual thing, goes all the way around. You really need two separate potentiometers so the wiper can travel all the way around on its own, so you need two of them. So that's how I sorted out which is which. So the sound level has been the same all the way through, or equal, both channels equal, until I got to this point, which I am now going to demonstrate. And this is the input to the two volume potentiometers, one input followed by another. I think there's music playing right now. I got the volume down on the tracer. I've had to use this tool to get in there, it's so tight. Here's one side.
The time to get started with Planet Fitness for no enrollment.
Here's the other side. That's the first time the volumes have been different. So the signal reaching the volume control is different. So somewhere between here, where I've drawn on red lines, and here, where I've jumped past all this stuff, there's a difference. So it's in this stuff. And that's where I replaced a bunch of capacitors. I'm probably guilty of making this happen, or I didn't replace enough. There's still a couple of original capacitors in there which I deemed to look okay. Or I did a solder error, or like a short, I've got a solder bridge in here, or I've got a cold solder joint, or. But the problem is on that board that is so hard to access from the top. So now I'm going to have to pick my way through this board as best I can. Now, there's a diagram here of the board, but it's, you know, it's a photocopy. It's not so good to look at, but it should be a little bit helpful. Very hard to see the back of this board. And on this schematic, you see all these numbers written all over the place here in the black boxes. So those are the same that appear here in these black boxes, and that's been very helpful for me to work my way through this so far. So input to the volume control, we're really talking about right here. So this line is good on one, not good on the other. I don't know which is which yet. I mean, this is just a diagram here. So I need to sort out which component it could be that could even be responsible for it. You know, when looking at it, it's good here and good here. It has to be because it's good here past this point. Then what is there that could knock it out? Well, that capacitor, probably a whole bunch of them in here could be responsible. That's my focus, is that little board which I did not want to remove from the radio entirely, and ended up doing kind of a strained job on it. I'm probably paying the price for that now. Or, like I say, there's always been a problem in it, and I just didn't get it when I did the capacitors. So I can access some of the board from down here, only the front. I can only access really the upper part of the back from the top. Coffee break time. So anyway, I'm moving in on the audio problem, that's for sure. I expected this to be very, very challenging, and it has been. What I found is that at this point, where I put the red dots here, the signals are identical. Same volume, affected the same way by the Brilliance switch, base switch, and the balance control is throwing the balance back and forth between these points identically. It all seems perfectly fine here. So logically, since the signal is coming into this area from the balance control, for it to be the same here, this has to be the same, that has to be the same, this resistor has to be the same, this has to be the same, this has to be the same, everything has to be the same. And with these controls being operated, base switch, Brilliance switch, and the effect is the same between here and here, everything I do, the conclusion is starting to come that the problem is right inside the volume control. I don't want to go there, but I'm not too sure what else to do. So I'm going to demonstrate that these 2 points are the same. It helps me to prove that I'm not off in la-la land here. If I show you the results I'm getting and go through the various tests, then maybe I'll find out I'm not correct about these 2 points being the same. Okay, so those 2 points. So just that, you know, one of the things about all these radio receivers is when the engineers really get going, they love to fool around with the tone balance, the tone control, and the loudness effect. So our ears don't hear the same with low sounds and high sounds when it comes to bass and treble. We don't hear the same relative level. Our ears are very insensitive to bass sounds at low volume, and it's probably a evolutionary thing where, you know, low sounds, we're trying to hear voices, maybe whispers, and so our ears have adjusted. So in a quiet setting, we still hear fairly well in the voice range. So we drop off the bass. I think you know, that's what's in my head anyway. So what the engineers have done here is, you know, the volume control, the main input is this top line here, which essentially is bypassing all this stuff. It's just coming straight on over from the balance, straight through to the top of the volume control. But as you turn the volume control up and down, the engineers want to compensate for the way we hear. So they've inputted into along the volume potentiometer resistance signals that they are tone controlling back here. So you see the bass selectors, bass switches here, the Brilliance switch is here, and their effect is pumped into, if I can use that term, pumped into may not be the right term, but let's use it, into the volume control along these lines here, which I have to imagine as you sweep the volume control up and down, you get a differing effect from the amount of bass coming in. So automatically, as you turn the volume up and down, the system is compensating for our lousy hearing. I think that's what they're trying to do. And they get real fancy with filtering and capacitors and resistors and all kinds of stuff in here. There's always a very complicated part of a radio to sort out. Basically, between the detector and the speaker, something like this is going on. Now, this is quite complicated. This is a German-built, German design, or German type radio, European type radio, and they go to town on this stuff. That's why they've got all these switches, and they just go to town on tone control. Whereas in North American radios, usually you've got, you know, in the simplest one, you've got a treble cut and nothing more. Other ones, you've got a treble cut and a bass cut, I guess. But not much more complicated than that in most North American receivers, although a lot of volume controls do have a tab to input. Often what I find is feedback coming from the total output. They send the feedback and jam it into the volume control. But on North American radios, the volume control tends to be back here in the circuit, and the tone controls come next. But in this radio, tone controls are happening up here, and the volume control is the last guy. I think it's the last guy. So, okay, so I want to demonstrate this being the same on both channels. We'll start with the balance control and demonstrating its operating. Good, perfect, guy talking. Okay, so just 1 second here while I relook at a pile of stuff. So I can get the... Now the hum you're hearing is coming from my signal tracer. It's not coming out of the radio. So you see I'm on 1 point. I'm right where this red dot is. That's one channel. This gets a little noisy here. That's the other channel. That's with the balance kind of in a neutral point. Well, not quite. So, uh-oh, music. Darn it. Okay, so I gotta pick another source. I'm gonna pick a voice source here because I'll get a copyright hit for sure. So let me change the input to the radio. Okay, I found some talk station on a station called The River, 101.3. I don't know where it is. But we're listening to one channel. Okay. The balance is all the way one way. Turn it down a bit. Okay. All the way one way. All the way the other way. So it doesn't cut it right out, but it makes a difference. Okay. So this is the loudest on this side. Now we'll go to the other side. And you get the same volume level. If I go in the middle, which is about there, and we go from spot to spot, let me turn it up just a bit. Exactly the same. So that's part of me saying this area is the same. Now another thing is Brilliance Control, which is right in here, and the bass control. So I'm going to operate those switches. Does it have an effect, and is it the same? So here's the Brilliance. You know, we're using a voice, so it's not so distinct. Plus my signal tracer has a little tiny speaker in it.
Now it does show you. Describe what you're doing here because.
Okay, I'm going to turn the volume down just a bit on the signal tracer so I'm not buzzing my wave. Go to the other side. No, wait a minute. I still have the bass control to operate.
It also shows you like hunting or shooting.
Okay, so I can hear a small effect from that.
That's a hefty bow you have. Wow.
Fly fishing. You make them know it's flying
Okay,
yourself, Randy.
go on the other side.
That's amazing.
Bass control. Again, a small difference, and the Brilliance.
That's awesome, and I just think it's so cool.
No problem with the button up here.
Doing something different with this, and I'm just looking at all the pictures that they have of you on the map.
It could make a difference. It's very, very slight if it does.
Honestly, I don't even
I think we just can't hear it because my signal tracer is not so brilliant.
beaten out the traditional look.
So what that tells me, let me turn it down now. What it tells me is that everything is operating exactly the same up to this point. This point, these 2 points. To be operating the same, I'm pretty sure all these components have to be operating the same also. This is all the same. So now we're going to take a look at the output of the volume control. Go back to that. These are those 2 shielded capacitors that I've left in. Watch it turn out to be those. Wouldn't that be something? So we can find the output of the volume control by going on those shielded capacitors. I've got to tip up the radio and do all that now. It's a little interesting. I've turned the radio off. Power's off to it. Sound's still coming through because all the way from here through here, that's just passive components. There's no tube, so I didn't even need to have the radio on to do this. I just realized. Well, that's helpful. Okay, so that's really helpful. Okay, so let's not have to tip the radio up. I should have realized. You know, that thought went through my head earlier, and I just went down right through. Okay, so I am now beyond the volume control, looking at either side of this shielded capacitor. That's these guys hanging right here, these 2 guys. The balance control in the middle, and I'm going to put this on one side. This is where the capacitor feeds to. Turn up the volume here.
Thank you very much, Shai. I never anticipated it would go this far.
We'll go to the other side.
We went to, and there's approximately 50 models maybe in each group.
Okay, back again.
The initial round. Good price.
No difference. No difference. So actually I've now cleared all this. So my suspicions in here were not right. somehow I did manage to solder all the new capacitors in there correctly, so it appears. Turn down my tracer there. So now I'm on my way out here. And I need to start examining things out here. So right away we're going right into these two tubes. We're going from these two tubes, which are boosting the sound. We're working our way through all this stuff. Presence switch and the alto switch. The alto control. What else is in there? I mean, how much tone control do you need in a radio? Oh my gosh, it's crazy. So that's what I do. I just carry on and kind of wait, not really waste time. I'm proving things out as I go. But boy, I thought, you know what probably happened was I jumped on these capacitors earlier. It probably had the balance control over one way. Or some other factor was entering into the difference that I detected, which caused me to work my way back here. So, you know, bit by bit, get more comfortable with the radio itself, which is still switched off. From here on in, I got to switch it on. But I should really get on the grid pin of these two tubes before I do that. The grid here is, well, they didn't bother putting the number in. Oh, it's on the other page. 2 and 8. So I get on to 2 and 8. It's a 10 ohm resistor. No. 10 mega ohm resistors here. 2 10 mega ohm resistors. So let's get, so that I've already been on the output here. I've already been on the grid. So I know the same signal is reaching these two tubes. What's coming out may be a different matter. 60 volts. 60 volts. My signal tracer. Hey, what happened to the picture? I guess I'm shining the bright page in the camera there. Come on back, camera. How come you won't come back? Yeah, I don't know. It was too much for the camera there. Hope I didn't burn it out or something. Why it's so dark? But why is this a great big thing here? Because there's a vacuum tube inside here, and the grid is what's coming out. So this is right onto the grid of a tube. So this is actually getting warm. I actually feel this warm. It's kind of nice. It's cold out again today. Snow today. What's happened to spring? Spring is really delayed. So that being a grid, I can apply that where the 60 volts is. It just makes a pop when the you know, because of the charge rush onto the little bit of metal that's here. Just a pop. No harm from that. So turn the set on and get myself ready to look at these two tubes and figure out, well, what happened to my camera there? It's just gone dark. It's not like that in my shop. Okay, not really sure what happened to my camera there going so dark, but I'm going to risk it again. It wasn't really the camera control that did that. So I decided, instead of working my way through this, I'm going to skip it all and find out what the two EL84 output tubes are listening to on their grids. What are they getting? So to do that, pretty hard to get on a grid pin underneath the chassis. So instead, I'm going to work from above this way. And I'm going to identify these two resistors. Well, I've already done it actually. R52 and R36. They're both 100K resistors. Found them on another document in the service manual, so I know where they are. I'm going to point them out. I'm going to turn on this radio. And we're going to check and see what the two, these are the two output tubes. So one of them is this one, and the other one is this one. Over here, I'm tapping. So I'll put my, I don't know which end's which offhand. I guess I could figure that out, but I'm not going to bother. I'm going to listen to both ends here and both ends there. The balance control in the middle, and we'll find out what those guys are being served. That'll tell me whether to go forward past the tubes. Is it the tubes themselves? I tested these right at the start, and I think they were both testing really good. So anyway, we'll do that. We'll find out what we get. I got to practice here before I turn on the radio. Do a little practice because sometimes what seems like a good idea in planning turns out to be crappy in execution. So I want to do something like that. And, do something like this. And then I want to do something like this. And something like that. Maybe there's a chance I can figure out one end from the other. Just by doing the test, it'll sound differently on either end of those resistors. Okay, I think I'm ready. Okay, I'm gonna turn on the set and get and do it. Okay, here we go. Now the actual speakers from the stereo are not connected, and the volume is turned. Oh, the volume's turned down. Well, we'll start that way. Volume down everywhere. Let's just try clipping on one of these. Now there shouldn't really be any voltage here. Shouldn't hear anything because my signal tracer is turned down. So we'll start there and we'll turn up some volumes. First the tracer. Now the actual radio volume.
Hunting.
Gee, I'll have to turn it up just a little wee bit to hear that.
Hefty bow you have. Wow.
Fly fishing. You making those flies yourself, Randy?
I do.
Oh my God.
Just holding this close to the circuit. Oh, funny sound. Oh, so what's happening is I'm bumping this with my finger. Trying not to. Okay, the other end of the same resistor for comparison. Okay, setting the volume on the tracer. That's one side. I would say it sounds the same on either side. That's probably what we should expect. Now the other resistor. Okay, that's pretty quiet. Let's compare again. Better go on the other side. Maybe it's the resistor. Oops. Okay, so that's the feed to one of the two tubes. You probably can't even hear that. I don't hear it either. Yeah, it's there. It's very quiet. Let me go to the other side again. You know, this thing can pick it up just hanging it here near these tubes. That's one. This is the other. Well, there's definitely a difference there. Let me just check the balance control. Make sure it's in the middle. In fact, let me turn it all the way one way and the other way. Okay, so this way is the loudest for where I have the probe. I'll turn the tone control. Not quite on camera. I'll turn the tone control. I'm going to swing it a little further. I'll turn the tone control the other way. Get a check on the volume now. Well, okay. I don't think there's any question. But what these tubes are being fed with is different from one side to the other. So what that means is I have to crawl through another circuit. So what we just did was test these 2 points here and found them to be different when they shouldn't be different. So it can be this tube, either of these tubes. This is a brand new NOS tube. So it's not likely to be that. Could it just be that this tube's a little weak? Or is it something going on in all of this? maybe pick a good spot that I can access fairly easily. You know, the alto switch is connected to the main line that's heading for the tube. If I can get on the alto switch on each side, it's not a switch, the alto potentiometer. Yeah, I'll get on the alto, I'll get on here, and we'll compare the signal strength of these 2 points, the loudness. That's my plan. Now to do that, I have to tip the radio up, because there's no way I can do this without tipping the radio up. Can't I look for C73? How about one that I've replaced? Well, here's one I've replaced, because it's a .01. That would be up on top here. Somewhere in there. Maybe I'll find these ones. This is C85 and C70. I'll do that. C8, and we can do either side of it. Maybe it's these capacitors. Shouldn't be. I've replaced them, didn't I? Yes, I did, didn't I? Okay. C85, C70. I'm going to hunt those down and get ready to test there. Okay, the 2 capacitors in question is this one that I changed, and this one here, this brown one, which I did not change because it looks good. .01, they're both .01s. So I'm going to want to put my test probe on those. Oops. Okay, let me turn up the... Okay, there we go. Again, I don't know one side from the other, but I'm guessing, I guess they're arranged the same way, but there's no reason to believe that. Let's go on one side here. I'll turn it up. Let's try again. Uh-oh. Maybe the podcast has stopped. Other side? What's going on? Then we'll do this one. I'm going to burn my hand on these tubes. Okay, I think I have my finger on the probe. Nothing there. I got the volume turned down. Maybe that's the problem. So I'm operating the volume control here, which is just a little bit off camera. Throw the focus off by doing that, but you know what I'm doing. It's not quite what I expected. Is my ground connection still on? Yep, everything's on. Ground connection for the... Oh. Where are you? Okay, balance was not in the middle. Balance in the middle now. Oh, I must be totally wrong here. I must be totally wrong. Where the podcast stopped. Yeah, maybe the podcast. That's what happened to me just off camera a few minutes ago. The podcast actually stopped. Yeah. Why is it doing that? Okay, play. I thought it was going to play one after another. Okay, you just never know where the problems lie. Okay, we'll go back on here. Problems lie with me and what I'm doing. Oh, volume on the radio. There we are. Okay, back in business. Okay, so now, volume comparison. This is one side. Exactly the same, both sides. Now we'll go to the other channel. Sounds the same. Get on the other side. me that capacitor's not doing the trick. Or did the podcast, did they stop? Sound like, and they just started. Let's go back. Come on. Oh, they're still talking. I had to turn the volume right up to get it. I gotta double check, make sure I'm on the right capacity. Let's go back to this one. See how much? I just turn a little bit.
I kind of done the center photos.
Hot tubes, man. Holy smokes. Should hear it.
I'm not.
Okay, before I jump to the conclusion that it's that capacitor itself, let's go on the other side of it. Wow.
Oh my god.
Really?
That's amazing.
I put my little gadget on my table.
So, okay, so we found the signal to be low on both sides of this capacitor
Awesome, and I just think it's so cool. Like you're saying.
as compared to the other one. I wonder what those people are talking about.
And honestly, I don't even see the.
Well, that's a very clear difference.
I can see a little bit of cleavage, and you have beaten out the
A bit of cleavage.
traditional look of a Maxim cover girl, which is quite amazing.
Now, let's just review
Thank
the
you very much, Sarah.
situation here. So I believe what I'm doing is I'm testing across these two capacitors, 85
and so that was the initial round.
C70.
And I came through there and
I don't remember that number.
super surprised.
85 and 70. Maybe I got on the wrong capacitor there.
The top line, and I came through that.
Okay, so we're going to, oh, right here. Hold some. 85 and 70.
We have like 6 models left.
There's 8 days left to vote as well.
Yes, exactly. This is from across Canada.
So I'm going to verify that those
And it's
are
the
the
kind of
right
thing where you can vote, like,
capacitors.
you can go-
Yes.
Okay, we'll turn that guy down. Jump on the schematic, or on one of the diagrams here. Okay, so this is the area here. And this is the one I was testing, 70. And the other one is kind of tucked right in here, 85. Okay, so now we gotta work our way. So it's low on both sides of the capacitor. So I don't think it's the capacitor. It's a nice looking brown capacitor there. Gotta work our way back now. Somewhere between here and here. There's not much in there now. There is a problem. That's my finding at this point. Okay, so I'm gonna study this a little bit and come up with a theory. Or at least what to do next. Okay, so what I've noticed is that these capacitors have B plus for these tubes on one side of them. 60 volts in both cases. Is it really there? I've got the set running on low voltage here. We'll raise it up. Give it just a moment. I just have to touch the correct size of the side of the capacitor. Still hear them talking there. Don't know which side's which. I got to take this off. Okay. It's in the way. So we're watching this voltmeter here. Oh, so 60. So it's 150 volts full scale. So it's gonna 60 is right in here. Are you there? Okay, I'm gonna get my hand in front of the meter. That's one side. Find out if that thing's leaking too. There's the other side. There's the 60. And I would go over here and the brown guy. Okay, look over. I don't see anything. Go over on the other side. I'm thinking maybe the B plus is off. That's why I'm testing it. Okay, so I think we can get at it from here. Just try not blocking my own. problem is to get the probe in place, then I got to look away. Okay, it's there. Whoa! Anybody see that? What happened there? I think it went sky high. Let's look at that again. 150, over 150 volts there. Okay, that's kind of interesting. Why 150 volts there? Now I know these two tubes are two different tubes, so I can figure out which one it is. Which one is it? So 150 volts. This is interesting. The tube I had to replace is the one that's got 150 volts on it. Well, how do you get 150 volts? How would you get 150 volts on here? How did they get 60? That's the first question. So, see, the 60 here comes through a network to 195. So there's up to 195 volts available. So both go through this resistor, and then they split on these two lines. Let me get a better pointer. They split on these two lines. This one goes through a 220 K 1 water, and up here 220 K 1 water. Okay, so they're the same, and from there it's a wire. It's the other side of this resistor is where I'm testing. So same thing here, it's exactly the same. So it's implicating this resistor, 220K, 220K, 1 water. How do you get the high voltage? The resistor has to go low. Is there a voltage divider thing happening? There is between here and I don't want to say that. The only way is for these resistors to be bad. Generally, my experience is resistors go high, but you know, my experience is my experience. Yeah, maybe my experience is crap. Maybe it's gone low. Well, they're 1 waters, and they're going to be handling the plate current, so they're hard-working resistors. Well, all of these. Can't be this one. Got to be, and the tube that we're talking about is this one up here with the crazy high voltage. Okay, we got to investigate this 220. I got to find it and investigate it. Yeehaw! Okay, so I just recalled I did the tube pin resistance measurements, and I completed this table. And you can see that both plates should be seeing the same resistance back to wherever they're measured. So here's one of them, EBC81. It's supposed to measure 320. You notice I don't have a green dot there. And this is the other tube, and this is where it should be, 320, okay, no green dot. Did I not do these two measurements? Did I, I miss it on this? Son of a gun. So I let it cool down a little bit. I'm going to pull those tubes out, and we'll just measure the pin resistance. This is a pin resistance back to the back into the power supply. It's a little tricky to do. Well, maybe I can find those resistors. Well, in the meantime, I'll do something. I'll do something. I'm getting really close now. Okay, so I measured it with my ohm meter here. They both measure 220. They both measure good. So if it's not this resistor, how else could you get a crazy voltage up there? Did I measure the wrong thing? This is just a triode. It's only got a high plate voltage. There's no other high voltages. So the current flow through the tubes controls the voltage drop in the supply resistors. There's no current flow through the tube. There's no voltage drop, and the voltage would go high. EABC 80. And, okay, so I'm going to have to test both these tubes now. One of them is essentially brand new. So maybe I'll start off by testing the bad guy. ABC 81. Which one is this? Is that? Which one is this? Is that? Okay, don't think too hard. Take any guesses. I got this diagram here. So the EABC 80 is the front one, and the 81 is the back one. 80, 81, 80, 81, 80, 81. 81 is the one that I changed. That's this one. So the old tube is that one. EABC 80. You can read the 80 there. You can't read the rest of it. Maybe that's an E. Well, okay. Maybe it's this all this time. It's a tube. That's interesting. It's a three section tube. It's a busy guy. One plate is dark. Oh boy. Okay, I have a hard time testing these tubes, but that's what has to happen now. EABC 80. It has to be this tube at this point. Okay, let me double check the settings there. I'm looking at a supplementary list of settings for European type tubes for this Stark tube tester. So let's see, there's four tests for this tube. Maybe I was lazy and I didn't do them all, but the first one is the triode, which is the one I think we would be concerned about, but I don't know, let's check it out. 6.3 EV 89070. 89070. 16 and 49. 16 and 49. We're good to go. Yeah, no, I mean it's got three sections in it. It's three different tubes in there. I guess all the plates are all fed the same way. Maybe there's a short... No, that wouldn't explain it. This is a tube that isn't conducting, according to my current theory of failure. Maybe my theory will be the failure. Let's take a look at some of the shorts. You're not flashing. You're not flashing. A tiny little weak little flash. Usually good tubes tend to flash this short light. Okay. The tube should test 630. 630 says get rid of it. 1000 says you should be happy. Oh my gosh. It didn't move at all. Okay, so maybe it's just not aiming right. That happens. It's a bit of a problem here. Push the button down, needle in the tube. It's dead. It's tricky business here. If the heater pins are the ones that aren't making contact, if that's what's happening, then, oh yeah, there it goes, there it goes. There she goes. 6, 7, wow, it's getting up there. It's almost 1,000. Okay, we're going to just carry on and do the other tests. So the next test is 06070. So 06070. 0607. 16 and 0. So we're not going to use the English. English on 0. And press P1 diode. OK above diode's OK. Diode's OK. P1 diode. Wow. Diode shouldn't really be involved in this. I'm using the phono side of things. The diode, the meter's here, but it's got to get up here to be diodes. Okay. Okay, EABC80, EV10, just change, yeah, 0107. So we just got to change the 0. Let me check just to make sure I got this set right. 06070. 06070. Never condemn a tube without double checking things. Next setting is 01070. So 01070. 16 and 53 on the English. 53, and I don't usually use the English thing, but I'll set it anyway. And we're pushing P1 for diode number 2. That's good. P1 diode number 2. The last test is 0203. So 0203 with a 0 at the end. 16 and 53 again. Diode number 3. Wow, how could a weak diode be involved in this at all? Let me just do the first test again. EABC80. Am I doing the right thing here? EABC80. EV8907. Right, EV8907. 0 on the end, 16 and 49. 16 and 49. 3000 scale. Reading should be above 630. 630 is a reject point. It's right up where it was. Tube tests good. Except for the one diode. Okay, gotta study up on the circuit now and figure out my next. Figure out my next. I'm gonna make a more direct measurement of the plate voltage. What I've done is I've put the tube up on a tube extender so I can get at the pins. Easier, and it's pin number 9. Number 9, and we're expecting 60 volts. The last time we saw this go right over. So pin number 9. 7, 8, 9, way around the backside there. Here's 9. 60. I must have done something wrong with the measurement. It was a wild goose chase. Goose chasing. Okay, so now what do we got? So now we've got a situation where the tube is okay, the tube voltages are okay. Somehow I got the voltage reading wrong. I can repeat that right now. Maybe I was just reading the wrong side of the resistor. That's why I got such a high voltage. So I'm just going to put the camera here so it's a little bit out of the way. So this is one resistor. That's the wrong side. That's the 60 side. The other resistor. That's the wrong side. What? That's both sides of the other resistor. It's open. Something's open. Something's gone open. There's no current flowing through this resistor, and that's why it's reading. Is it exactly the same? Let's take a real reading here. It's the 500 volt scale now. I definitely got the right resistor here. The actual voltage is, it's the 195. We got it's 195, and it's exactly the same on both sides. So there's no current flowing. So for some reason, there ain't no connection between that resistor, this resistor, and the plate. Now that would certainly kibosh everything. So So what have we got going here? So we've got a treble control with a resistor protecting it. No, that wouldn't help. If this were shorted, there'd be even more current flowing, and this voltage would drop low. And this treble control would be crazy if I turned it. It would make lots of funny sounds. So we have this. There's no current flowing. The resistor measures okay. Cold solder joint somewhere between here and here. That's a bit of a long shot. You know what I can do? I can repeat. I can do the measurement that I didn't do, or at least I didn't mark on the sheet. So it's a pin 9 measurement. I can reason this out myself, I think. So what if I read it to the chassis? Well, see, it's going into the high voltage supply. So reading it, that's why you have to read it to the. Okay. I'm going to finish the thought. I'm going to get ready to do that. Okay, so the reading I'm supposed to get is 320K when measured back to the high voltage power supply to right there. So this point hidden underneath the chassis is produced by wire all the way to here, if I remember right. So I'm hoping I remember right. To here. So we should see 320 here. What do we get? It's pretty darn close. No, nothing's wrong. Everything's fine. There's no problem. Bad sound is my imagination. Oh my gosh. What has happened here? Time to stop. Think hard. Thinking is hard. Okay, so I've tipped up the radio so I can get at the output of the rectifier, high voltage rectifier, which is right here. Pretty sure I was on the other end of this wire, which snaked its way to right through the radio. Put my meter on, grab the other probe, try not to get confused. Let's just check, make sure we're zeroing okay and all that. Now I'm going to get on pin number 9. We're going to see what happens here. Pin number 9. Oh, jeepers. Turn this further. Pin number 9. There it is. Oh, yeah, better reading. 320 exactly. I almost pushed this radio over. Close. Right, it's right on the money, isn't it? 320, isn't that exactly what this says it should be? 320K. Yeah. Right. Glory. Glory be, there is no problem in this receiver. It's just all. Okay, just on a long shot. 6, that tube is the same as a 6T8, and I have a few. So I'm going to find a good one in this bag. These are all working tubes. I'm going to find a good one, and we're going to stick that in the radio and just see what happens, because. So I retested the original tube, this one here, using another tube tester, different tube tester. Got the same result, one diode low, everything okay. You have an alternate tube, shorter, and we're going to put this in and just see what happens. I can't imagine this is going to help out the situation, but I just need to do it to eliminate things. So I'm going to stop and just get that set up. Okay, this is the last thing I'm going to do today. Give this guy a test. Volume down, balance in the middle, hooked up to the speakers up above, yes. Podcast running, yes. Power on. Oop, wrong thing. Volume up.
time was this?
Right before 6 o'clock, like 5:55, right before we went on the air here, babe.
Any damage or anything like that?
So what's happening is the balance is upping and downing the volume on the channel you can hear. The other channel is silent.
Wait a
Which
minute.
one?
Which one?
No, you know what? It wasn't. It was one of the newer ones. It was actually a Greta Van Fleet album. Sorry, I got
No difference. We're exactly the same spot I was in when I started this morning. Except I've gone through an awful lot of this circuit and learned lots more about this radio. And I'm better prepared to take another run at it. But not today. I'm done for today. So thanks a lot for watching. Hoping you found that interesting. Too bad it didn't end up in the in a glory spot, but I think I'm getting clearer picture of where the problem must be. It must be somewhere in the radio. Thanks a lot for watching. See you tomorrow.